Hi everyone, and welcome to a new tutorial of sound particles. For this one I haven't planned anything. The idea is to simply open sound particles, start importing some sounds, messing with some parameters, and this way I hope you can learn something new about sound particles, and also I hope this tutorial can enhance and sparkle your imagination, and the next time you open sound particles you can get some ideas from this tutorial. So without further ado, let's start by opening our session and just doing something. Alright, let's start with an empty project. Let's start by adding a particle group. Then we'll add our microphone. I'm gonna change the type of microphone to ORTF because I think it sounds better for this type of highly complex events. Next, we should select our track, and before adding the audio files, let's change the shape of our particle system. In this case, I'm going to choose a rectangle. Let's set this to 1 kilometer squared. Now we'll change the number of particles from 100, which is the default value, and let's say 250 particles. Now we can add our movement modifiers. Let's start with straight line velocity. Let's keep the default values for X, Y, and Z. As you can see, our particles are already moving. Additionally, it is also interesting to note that some particles are really close to the center, to the microphone, and the others are really far away from the microphone. The ones that are really close to the microphone will add to a more detailed sound, while the others will add to the background noise and the rumble of the overall soundscape, which is exactly what we want. By adding our straight line velocity, we are actually making all particles move, so we are adding a lot of Doppler effects to the overall soundscape, which really adds to an organic tone to the overall soundscape. Of course, we can also add rotation modifiers. As you can see, our particles are rotating around the microphone. Maybe rotating too fast. Let's change the azimuth velocity to 10 degrees per second. Let's also add some audio modifiers, random gains. In this case, let's have our particles being reduced between 0 and minus 12 dB. Let's also add some delays. Eventually, let's say we want our particles to be delayed between 0 and 10 seconds after we hit play or render. And let's also add some time pitch shifting and change it to minus and plus 3 semitones. And let us start adding our audio files. For this example, I think something like crashes and debris would be a good starting point. Let's randomly select some of the files that we have here. Let's do something like glass. I really think glass works for this kind of examples. These files are from Pro Sound Effects, by the way, and let's hear how this sounds. Okay, maybe some additional files will help us get a better feeling of what we want to achieve, very randomly importing sounds. I think we might be getting there. This time, instead of adding audio files, I'm going to add an audio track. I want to add a rumbling sound. Let's look for something like tones or rumbling. Let's add some modifiers. Let's add random gains just to add more variation to the particles. And let's also add some random delay. In this example, the random delay will be very useful because, as you can see, the group that we just created is much shorter than the original one. So this is a useful trick that we can use. So I'm going to try different values for random delay so that the groups end more or less at the same time. Okay, 2 minutes, it does the trick. I'm going to also add some pitch variation, but in this case I don't want 1 octave up and down. I only want my particles to be pitched down, not up. So I'm going to set a minimum value of -5 semitones and a maximum value of -3 semitones. Okay, I'm going to apply this and I'm going to mute my other track. As you can see, now my group for the rumbles is bigger than previously, because by pitching the particles down we increase the duration of these particles. So I'm going to change the delay to a more appropriate value. Okay, and let's give it a try. I want the rumble to be more overwhelming. Okay, so let's increase the volume. One of the things I'm gonna try is to increase the radius of our torus. This way we don't lose the detail regarding the earthquake events closer to the center, closer to the microphone, and not only in terms of volume but also in terms of the normalization. And let's also add some rotation movement, very small, so that our rumble keeps changing in terms of balance of the channels, and I think it gives a very organic sound. Okay, so around the 40-50 second mark, the earthquake events, they organically start fading out. So I think it makes sense for the rumble to also fade out. So I'm going to add a volume automation, and I'm going to create an automation point around the 45 second mark, and then I'm going to double click to create another one. And let me just bring it down and extend it a little bit, like so. Okay, I'm gonna do the same for the earthquake sounds, and I'm going to extend this a little bit further. And let's hear how this sounds. Okay, so I'm going to change the fade out of the earthquake events. Okay, like so. And also, I think that the beginning is too sharp. There are too many events happening right at the beginning. So what I'm gonna do is to drag this track to, let's say, 10 seconds, something like that. Also, let me play a little bit with the random delay. Normally we have a minimum and a maximum value, and we have a flat uniform distribution for the particles to choose between a range between these two values. In this case, I want my events to be centered at a certain time. Okay, in this case by default is 5 seconds because we have 0 and 10 previously for the uniform. Okay, but I want it to be centered around 30 seconds. So the idea is to have less events at the beginning and the end and more events in the middle. So I'm going to choose middle value of 30 seconds, and I'm going to also change the standard deviation so that I can control the proportion between the events happening in the center and the events happening at the edges. So I want my middle value to be 30 and my maximum value something like 2 minutes, 120 seconds. Okay, let me change the standard deviation. Maybe this is too much. 1 minute maybe, okay. And let me decrease the standard deviation. So as you can see down at the probability distribution, we have our event centered around 30 seconds, which corresponds to the 30 seconds on the timeline, and little events happening at 0 seconds, as you can see, and little events happening at the 60-second mark. So the idea now is to change the SID so that I have more events happening at 60 seconds edge than at the 0 seconds edge, as I think it makes more sense. So as you can see, we got that. We have more happening at the end, at the right edge of the histogram. So I think we are ready to apply this, and let's check out these sounds. I'm going to increase the difference between the edges and the center value by increasing the standard deviation, because I think the build-up is too slow. And also I'm going to bring the earthquake track closer to the beginning, because I think there's too much of the rumble sound by itself. And let's check out these sounds. Okay, so this was our earthquake, little demonstration on how to create something like an earthquake. Of course, it can be applied to many things. I hope you had a chance to see what you can do, some hidden gems, some tweaks that you can use for your project. Yeah, and let's go to the next example.